What became apparent with a project of this size and magnitude was that a process needed to be put in place for the testing, because it was absolutely fundamental that once we started laying the boards down with the tracks and the wiring already on, that we knew we could not go back and redress any issues that we found. So it was essential that we were actually doing testing actually as we're going through with the assembly of the layout. We started off with a track plan, and this was built up by Steve, that worked out what we was needing and what it was going to accommodate. From that track plan we could then identify what size baseboards we were then needing. So those baseboards were then manufactured, but we only manufactured the first layer. In this extension we've actually got 4 tiers of the same track plan baseboard layout. And it was essential that once we get the first layout built, we could then replicate the same processes and the same track plan and the same design all the way through for the other 3 layers. We started off with the baseboards, and we then applied a greaseproof paper on top, where we were then able to lay the track down according to that track plan and the wiring diagram. With that, we were then able to identify exactly whereabouts on the board the wires were going to go through, and also where the points were going to be positioned, and basically all the lengths of the sections. So once we got the track plan or the track laid down, we wanted to recheck the length of all the sections to make sure that what was in the original plan was actually true and accurate for the length of the trains we wanted to fit in those sidings. So in order to do that, we used sections of rope, and the sections of rope of various lengths, but all accommodating a set train length, because each section needed to accommodate a length of train. We were then able to apply that onto the track, and the beauty of using rope is that it goes around corners far easier than what a normal conventional tape measure would. So at least we knew that each section was the full length and the correct length. Once that baseboard had been tested with the track plan and the lengths, we then lifted everything back up again. But we used the greaseproof paper as a template we could then apply to each of the various 4 layers as and when the other 3 layers were actually then manufactured. This is where we then came about from devising a testing plan. So once we'd identified where all the wires were going to be, with all the black wires, all the red wires and all the air dots and all the point motors were going to be positioned, we then needed a plan that was going to help us go through to make sure that in this situation we could test it before we actually put it down onto the baseboards.
With such a large amount of wire, we need to have a very thorough testing protocol, because as I'm sure you can imagine, we really don't want to have to go back down to the bottom layer once it's all in place if there's an error. We've designed a structure which encompasses 3 aspects of the boards. We're looking at the droppers and the wiring itself, the dots or infrared detection of train boards, and also on the point motors, the tortoises. The track feed section of the testing is, first of all, we've got to make sure that the track feed droppers themselves are located on the board in the right physical location compared to the block diagram design. We've also got to make sure that there's continuity between the dropper itself and also the wire at the end of the board. In this case, it's not very far at all. And last of all, we've got to make sure that for every 2 foot of track, there is a track feed dropper attached to it, and this will ensure a healthy DC signal purely because it covers such a long distance.
So according to the test plan, we've got a test track 3,
right,
which is section red 21. So you've got the feed there that's ultimately going to connect through to the block detector, and then these are the track feeds from the droppers. So that's the first one. So once we get the beep, where we've got connectivity, we put the clipper on. 2. Put the clipper on. And then the final one, put the clipper on, which means that section is now full and complete, so we can update the test sheet. And then put the clip on red 21. And then we can then progress through to the next section.
For the infrared detection of train units, or the dots, there are actually quite a number of things we need to ensure. First of all, these units will have been tested before they even reached the layout to make sure they function. Once they're installed in place, first of all we need to make sure that just by waving our hand over the infrared emitting part that the dot will actually fire. We need to ensure that the LED will illuminate, which is the indicator that all is functioning well. We also need to check that the switch inside closes, and to also ensure that once the hand has been moved away from the infrared section, that there's a 5-second latency before the switch and the LED opens and turns off.
We're now testing the air dots. So as I place my hand underneath the air dot, the circuit closes and it then gives a positive signal. To help us with the planning of the orientation of the point motors, we devised a test rig. We have 2 right-hand points, 2 left-hand points. The difference between the points is on the right-hand one up here, which we're calling type A, it's where the point motor is positioned prior to the switch. And this is indicated by the screw markings which is securing the point motor below. On type B, it's where the point motor is actually positioned after the switch. On C, it's after the switch, and on D, it is before the switch. So if I rotate round, you'll notice that the top one, we've labelled A, the top right hand, the other right hand is B, and the left hands are C and D. Now as you can see here, the point motors are slightly different in their orientation. And the key to this is that the wiring is slightly different. Because the point motor is reversed in its orientation, the wiring coming out is slightly different. So there's 4 different variations of the wiring depending upon whether the point motor is before or after the switch and whether it is a left or a right hand. And this is related to a little bit later on when Tim talks about testing point motor type D, which is a left hand, which is, as we can see back here, type D is where the point motor is positioned before the switch.
The first thing we need to double check is that the wiring schematic or the relative positioning of the point motors is correct as we expect it to be. Okay, so we can confirm that this point motor has been identified as a D point motor, and then we can confirm that over here on the white chop block we get red for the tortoise power and track power, black track power, orange frog polarity, blue for the sensor return, yellow for the sensor feed, and then black for the tortoise power supply return. We also need to double check that the point movement of the blades is in accordance with the standards for thrown and closed. We also need to ensure that the frog polarity changes correctly when the blades go each different direction, because we're using electro frogs. And last of all, we need to ensure that the various switches inside the tortoise motor closes properly and we get proper feedback for it. When all the various aspects of the testing have been covered and they've all come up good, the next stage will be to physically lay the boards in permanently and then to lay the track.